Hello, welcome to the 2018 calculus speedrun. Well, I mean, not really a speedrun, just walkthrough. So let's get into this. So question 1A. Actually, I should probably have lots of these prepared. Yeah. Okay, use the unit circle shown below or some other method to prove from the first principles cosine alpha minus beta is equal to cosine alpha beta plus sine alpha beta. So, I'll show both the methods actually. Question 1A. So, how do they want you to ask? So basically, so let this distance from O to R, how we can work that out is, so we can actually, we can also see that this angle here, this angle is actually also alpha minus beta. Yeah, it might be hard to see, but since this is alpha and since this is alpha and, oh no, oops. Since this is alpha and this is beta, we can take this part away, and that will mean we're taking beta away from alpha, so this angle is also alpha minus beta. Okay. So, wait, let me pull out my formula sheet. Scholarship calculus formula. So we can use the cos. So we can try to find this distance PQ, and we can try finding this distance RA. So we can get two things and equate it together through different ideas. So to get this PQ, we can use cosine rule, which is just let me see. Where is it? Where's the, oh, here it is. C squared is equal to A squared plus B squared. That's 2AB cosine C. So, PQ squared is equal to, oh, by the way, this is a unit circle, so all of OQ and OP are both radius to the circle, so it will both be 1, since unit circles always have a distance, a unit circle is a circle around the origin with the radius 1. Minus 2 times 1 times 1 cosine, yeah, so this angle is alpha minus beta. Cosine alpha minus beta. 1 squared plus 2 take away 2 cosine alpha minus beta. I believe that is equal to PQ squared. Then to get Wait, what was it? PQ squared. P is a cosine. Hmm. Right, actually, this point here is, so if we create it, if we create a triangle here, this vertical distance will be sine alpha because this angle is alpha, and so so this point will be cosine alpha sine alpha. Respectively, this is also cosine beta sine beta. Hmm. Cosine, cosine, so this distance minus the, so um how do I do this? I chat it. Wait, I'm not. I don't. Okay, I'm sorry. I give up. Um, because I don't know how I don't know how to. Okay, I'll show you. I'll show you the other method. So eta I. So cosine theta plus I sine theta is equal to eta I theta. Then so eta I alpha over e to the I beta is equal to e to the I alpha minus beta. Then we can just say cosine alpha plus I sine alpha all over cosine beta plus I sine beta is equal to cosine alpha minus beta plus I sine alpha minus beta. We multiply the denominator by the conjugate. Cosine alpha plus I sine alpha cosine beta take away I sine beta all over cosine beta plus I sine beta. cosine beta, take away I sine beta is equal to cosine alpha minus beta plus I sine alpha minus beta. The things that creates cosine alpha cosine beta plus, oh no, take away I cosine alpha sine beta plus I sine alpha cosine beta plus, take away a plus, sine alpha sine beta all over, oh oops, wait, oh wait, what, yeah, all over cosine beta, oh no, cosine squared beta plus sine squared beta, but this is actually just 1, so cosine alpha cosine beta, take away I cosine alpha sine beta plus I sine alpha cosine beta plus sine alpha sine beta is equal to cosine alpha minus beta plus I sine alpha minus beta. Pair the real parts with real, then we get cosine alpha cosine beta plus sine alpha sine beta is equal to cosine alpha minus beta, which indeed is what we were after. The diagram below shows a circle with center O. There's a fixed point inside the circle. P is a point on the circumference. Where should P be located in relation to A so that angle APO is maximum? So O is the center and A is a fixed point. So yeah, here. So let's say this is a center. A, O, and P. So this is a fixed point. So, and the P goes around a circle. Actually no, since A is a fixed point, this distance will always constantly stay the same. It will always stay the same. And even if the point P goes around the circle, even if point P goes around the circle, even if point P, let's say it goes around to like here, let's just extend that, then even if point P goes to here, so OA is a fixed point, so it's still the same, but this distance is still the radius and this distance is still the radius, so the distance, therefore distance OA and OP are always the same, no matter the displacement of P. So then from this we can use the sine rule. Sine A over A is equal to sine B over B. So that creates so sine sine right, so this is with here, and this and this distance here, and OP is here. So sine sine P A O over P O is equal to sine O sine OPA over OA, and this is APO, so OA sine PAO over OP is equal to sine angle of APO. And actually, so we want sine APO to be a maximum, yeah, but then OA and OP are the same. So the OA and OP are, these two distances are always constant. So we can let OA over OP equals to K, which is a constant. So K sine PAO is equal to sine APO. And for a sine graph, always just continues to keep on going like this, where here is 1. Just draw that nicely. So here is 1, which is the maximum point, and here is -1 maximum point, and so the maximum number that sine can be is 1. So, and for sine PAO to be 1, it must be pi over 2 or 90 degrees, and So ish. So therefore, alright. So it should create this. We should create a right angle triangle since this is P. So sine APO should sine P. Wait. P. Oh no, this is A and this is P. So sine PAO should be 90 degrees. So this. So yeah, this should be created. Therefore, P should be placed perpendicular to A. Okay. Then question 1C. So cosine theta, prove the ID to cosine theta over 1 sine theta, take away sine theta over 1 plus cosine theta is equal to 2 cosine theta minus sine theta all over 1 plus sine theta plus cosine theta. So I've done this question many times. To be honest, I did not get this first try. I had to see it. I did not get this question first try, but this is quite a evil question. This is quite cursed. So we want to equate the denominators. So cosine theta is 1 plus cosine theta over 1 plus sine theta 1 plus cosine theta, take away sine theta 1 plus sine theta all over 1 plus cosine theta 1 plus sine theta. Oh yeah, let me just say left hand side is equal to this. So let's expand that out. Cosine squared theta plus cosine theta all over all over 1 plus sine theta plus cosine theta plus sine theta cosine theta, take away sine squared theta plus sine theta all over 1 plus cosine theta plus sine theta plus sine theta cosine theta, which is equal to, so minus, so cosine squared theta, take away sine squared theta plus cosine theta, take away sine theta over, actually I don't think, was I supposed to expand that? I'm not sure. Oh wait, okay, I know. Over 1 plus cosine theta plus sine theta plus sine theta cosine theta. Then this can be factorized into cosine theta take away sine theta plus, oh no, not plus, just cosine theta cosine theta plus sine theta plus, there is, here in this, I'm gonna just write a 1 in here, so just to prove a point after cosine theta take away sine theta all over 1 plus cosine theta plus sine theta plus sine theta cosine theta. So this one here, because of this, so like terms, so we can actually factorize this into, we can, and then these are the other terms, so we can actually factorize this into cosine theta take away sine theta and cosine theta plus sine theta plus 1 all over 1 plus cosine theta plus sine theta plus sine theta cosine theta. Then, so we have this term here, and what we can actually do is, actually no, we can't do anything yet. So because of this 2 here, this is quite a, this is a subtle hint to what we need to do, but that I don't, this is what you need to do is so dumb. So 2 cosine theta take away sine theta cosine theta plus sine theta plus 1 all over 2 plus 2 cosine theta plus 2 sine theta plus 2 sine theta cosine theta. Then you split this, we get this 2, right? Split into 1 plus sine squared theta plus cosine squared theta, which gives us 2 cosine theta minus sine theta, 1 plus cosine theta plus sine theta all over 1 plus 2 cosine theta plus 2 sine theta plus 2 sine theta cosine theta plus sine squared theta plus cosine squared theta. And this can be factorized into, let me just write up the top part, cosine theta, so 1 plus cos plus sine theta, it can be factorized into 1 plus cosine theta plus sine theta all squared. This is, yes, this just don't, it's just very dumb in my opinion. Then cancels out, which gives 2 cosine theta sine theta all over 1 plus sine theta plus cosine theta, which is equal to the right hand side, QED. Give the exact value for which the function f is discontinuous. So for a function to be discontinuous, it must, so this will be a smooth curve, but when the denominator is 0, we'll split off to here and like this, or like this into this. So for the functions to be so for the functions for if x to be discontinuous, denominator must equal to 0. We can easily see this, so 3x plus 2 equals to 0, x equals negative 2 over 3, 5x take away 3 equals to 0, x equals 3 over 5, then x squared take away 5x plus 3 is 0, then I think I can just plug it into my calculator, then 1, negative 5, 3, and x is equal to 5 plus minus square root of 13 over 2. So at these values, the functions are discontinuous. So question I find the limit of fx. Find the limit of x if x is the limit by just a half. We can actually just plug in half to all of these, can't we? So 2 brackets half squared, take away 1 over 3 half plus 2, 5 half, take away 3, take away 2, take away 3, half over half squared, take away 5 half plus 3. We plug this into my calculator. Hopefully I don't make a mess up. So 2 brackets 0.5 squared, take away 1 over 1.5 plus 2. 2.5 take away 3, take away 2, take away 1.5 over 0.5 squared, take away 2.5 plus 3, which is equal to negative 8 over 21. Show that the graph of x, y, and x squared take away y squared have a perpendicular tangent at their point of x intersection. So we can arrange the first equation into y equals the square root over x. Can replace this into the second equation, so square root 2 over x squared is equal to 1, x squared take away 2 over x squared equals to 1. You can rearrange that to x to the power 4, take away x squared, take away 2 equals to 0, then let a equal to x squared, a squared take away 2 equals to 0, a take away 2, a plus 1 equals to 0, a equals 2 and negative 1, negative 1 equals to x squared is not possible. Therefore, 2 is equal to x squared. And oh yeah, x is equal to plus minus square root of 2. And so in where x equals square root of 2, y equals 1, x equals negative square root of 2, y equals negative 1. Therefore, our points of intersections are square root of 2, 1, and negative square root of 2, 1 are points of intersection. Then we can implicitly differentiate. So if there's so when we differentiate xy equals square root of 2, break it up into f dash g plus g dash f. Then every time we differentiate the y part, we add a dy over dx. So f dash g, that's just y. G dash will be differentiating y, which is dy over dx times x is equal to 0, since deriving a constant will be 0. Dy over equals actually no, wait. Oh wait, actually negative y over x 4 equals square root of 2. And so let's derive the second equation. 2x. Oh wait, what's that? X. Oh, actually, I don't think. Over dx is equal to negative x. Yeah. If yeah. I don't think I even needed to calculate the points of intersection. Actually, I might just write it down in case. The point of the it's square root to 1 dx is equal to, right, x squared. Oh no, actually no, this is just x over y. Yeah, then this is the dx. Yeah, this is, yeah, dx of xy equals square root of 2 of dy over dx at square root 2 1 is equal to that is negative y over x, so negative 1 over square root of 2 x squared, take away y squared, plus 1 y over dx at square root of 2 1 is equal to square root 2, which perpendicular. Then yeah, if we just test the other two possibility, xy equals square root of 2 dy over dx at square root of 2. No, it wasn't negative square root of 2 actually. Wait. Negative square root of 2, negative 1. Square root of 2, negative 1 is equal to. Actually, no, they just cancel out, so equal to negative 1 over square root of 2, and x squared take away y squared equals 1 dy dx at negative square root of 2 negative 1 is equal to square root of 2, which is actually no, I think perpendicular I can just write here, this perpendicular. Let me just show my graph. Actually I can't see on my graph, never mind. Okay, so a loading system is to be designed so that 3 towns A, B, and C are connected. As shown in the diagram below, the towns form an isosceles triangle AB equals AC equals 50 kilometers, A equals, and BC equals 60 kilometers. The system is to be designed to minimize the total length of loading. This system is designed so that there's an intersection point at a point D such that there are 3 straight sections of load AD, DP. This is calculus to find the location of D that gives minimum length of loading. Show that this length is 40 plus 30 square root of 3 kilometers. So let's 2C. Let's see. If we create a triangle like this, D A C B, AB equals AC equals, so this is 50, and I believe BC is 60. Oh, barely drawn. If we break this into half, then midway through 60, then this will be 30. This will be 30. Therefore, this horizontal distance in 50, 30. This will be 40. This distance from A to midpoint of BC will be 40. Then let's name this, let AD equal to X. So this, we've named this to be X. So 30 use calculus to find the location of D that gives the minimum total length of loading. Alright, so this is 40 take away X. So we want, then BD squared. So this is 40 take away X, then this length is, so we can create this new triangle here. 30, 40, take away x, and BD. So we can say BD squared is equal to 30 squared plus 40 take away x all squared. Yeah, so we have two of those, so BD squared, actually I believe on x squared take away 80x plus 1600 plus 900, which is 2500. Square root of that is equal to BD. But then we have, so BD is equal, yeah, BD is equal to DC because of symmetry. So from optimization, we want to get the length as a function, then differentiate it to find the minimum or maximum. This is equal to 1 plus that's 0.5, so that's half. Then that cancels out, so 2x take away 80 all over. That's how chain rule works. Yeah, I hope so. I forgot. Yeah, I'm having short. I hate doing chain rule with big numbers and lots of functions. Right. Yeah, chain rule if dash. Yes, it is. That cancels out. So 2x take away 80. Square root of x squared take away 80 is plus 2500. That is, so set length dash is equal to 0. 2x take away 80 is over square root of x squared take 80x plus 2500 is equal to -1. 2x take away 80 is equal to negative square root of x squared take away 80x plus 2500. We can square both sides. 4x squared take away 320x plus 1600 is equal to x squared. Take away 80x plus 2500. 3x squared take away 240x take away 9 equals 0. X squared take away 80x take away 300 is 0. What would that equal to? 1 negative 80 negative 300. That's, I don't think that's, I got negative. Did I go wrong somewhere? Right. That is negative 900. 4x squared take away 320x. Oh no, that's 6,400. 6,400 take 2,500, which take away 3,900, 3,900. Oh no, that creates x squared take away 80, x take away 1,300 equals to 0. So let's hope this gives a better number. That still gives a very awkward number. I got 40 plus 10 square root of 29. And what do you want? 30 plus square root of 3. 4x squared take away 320x plus 6,400 is equal to x squared take away 80x plus 2,500. 40 plus minus 10 square root of 29. So that just feels wrong. So 40 minus x all squared is plus 30. 40 minus x, right, that is 40, then 40 minus x. 40 minus x all squared plus 30 squared is equal to bd squared. So bd, so 2 of x um, 2x take away 80 square root of negative x squared. We do have this 2x take away 80. So that equals 0. 2x take away 80 equals negative square root of 80 x squared plus 2,500. 4x squared take away 2. Yeah, this should be 100. Take away 160. Take away 160. Should be 320x plus 6,400 is equal to x squared take away 80x, so plus 3x squared take away 240x. Oh, no, that's plus. Actually, does that matter? Oh, okay, yeah, thank God. Right, actually, that still creates. It creates 40 plus 10 square root of 3. Is that 40 plus minus 10 square root of 3? But then, if x is equal to 40, no, 40 plus 10 square root of 3 is like 57. So that is not, that's not applicable, since, but the total length of hair is 40, so this, so 40 plus 10 square root of 3 isn't applicable as too big. Therefore, 40 minus square root of 3 is the only answer. But then, so this 40 minus 10 square root of 3. How should I explain this? How should I explain it? Right, do I need to Do I need... Okay, I need to explain that this is a minimum. Wait, can I just minimize the square this time? Actually, no, I don't think I can. So x equals 40. So I think it's just where dA is 40 minus 10 square root of 3. Yeah, is min. Show that this length is 40 plus 3. Wait, so this is 40. So this length is 40 minus 10 square root of 3. Oh. Then here, then this part is 40 minus 40 minus 10 square root of 3, so that's just 10 square root of 3. So here is 10 square root, oh actually yeah, that was pretty obvious. 10 square root of 3, 30. So db, oh, bd, oh yeah, squared is equal to 10 square root of 3 all squared plus 30. Yeah, it's 30, yeah, that it's 30 squared, square root of that, of 10 square root of 3 all squared plus 30 squared is equal, yeah, let's just square root that, then 20 square root of 3, so AD plus BD plus DC is equal to 40 take away 10 square root of 3 plus 20 square root of 3, two of them, which indeed is 40 plus 30 square root of 3 kilometers. Actually, I need to show that this indeed is a minute. So I need to... L dash is equal to 2x take away 80 over x squared take away 80x plus 2500 square root of that. Should I chain rule? I think I should just... I think it's better to just product rule actually. Efficiency is key. So if dash is 2 brackets 2, yeah, x squared take away 80 plus 2500 to the power negative half. Let me divide that again. So 2x take away 8 plus half 2x take away 80 all squared times x squared take away 80x plus 2500 all to the power negative 3 over 2. Then we put 40 take away 10 square root of 3 in here, which 40 take away 10 square root of 3 in here turns into 2 squared. 80 brackets 40, take away 10. 3 plus 2,500 to power negative 1 over 2 plus half 2 brackets 40, take away 10, square root 3 80 all squared times you take away 10 square root of 3 all squared, take away 80, 40, take away 10 square root of 3 plus 2,500 all to the power negative 3 over 2, which is equal to, which gives 0.0723 is minimum. Yeah. Question 3. Using a suitable substitution or some other technique, evaluate the integral. So, question 3 AI. Go from 5 to 0. 2x take away 5. 2x plus 5 dx. Let u is equal to 2x plus 5. So du over dx. Du over 2 is equal to dx. And then we can actually just rearrange. So u take away 10 is equal to 2x take away 5, which is this function. So and then we need to substitute the limit, since this limit is for x. So we u equals 5 brackets 2 plus 5, which is equal to 15. U is equal to 5. I put the brackets the other way. 2 brackets 0 plus 5, which is equal to 5. So the upper limit is 15 and the lower limit is 5. So 15, 5. So we got u take away 10 is 2x take away 5. So u take away 10. Then we got u square root of that is be u to the power of half. Half u over 2. So integral of from 5 to 15 of u to the power of 1.52 take away 5 u to the power of 0 du. That'll be 5 over 2, so 1 over 5 u to the power of 2.5 take away 3 2 over 3 5 u. Is that correct? 3 over 2. Yeah, I think that is correct. 1.5 15 5 so 2.5 2.2 10 over 3 1.5 take away, I don't think there's any constants you can pull out. Right. Right, 5 over 5. Right, that's 2 over 5. Right, then that's 5 over 2. Right. Wait, 5 over 2. Wait, that's it. I am having contemplation. Oh no, that is 2 over 5. I was having measure. Oh no. Let's put it into my calculator. 1 over 5 brackets 15 to power 2.5. Take away 10 over 3. 15 to power 5. Take away 1 over 5. 15 to power 2.5. 10 over 3. Brackets 5 to power 1.5. Oh, right. It's definitely incorrect. It's 10 over 5 over 2. Then it's 2 over 3 over 2, which becomes half. We don't go wrong. Right, let me just check. 1 over 5 is 15 to the power 2.5. Take away 10 over 3. And 15 brackets 10 to the power take. Oh, that's. Why did I input 5 for those? Oh, okay, that seems better. That seems. Wait, let me just check with my calculator. 2 x take away 5 square root of 2x plus 5 0 to 5, which indeed, okay, is equals 6.7225. Okay, so explain why the method used in I cannot be used in the following. It's not method, it's just that the integral is just invalid. It's not even I think it's just because the integral is invalid since lower limit will cause square root of -5, which is invalid. A Lorentz curve is used to study the distribution of income. The diagram alongside it shows a Lorentz curve and the line y equals x, where x is a cumulative percentage. Actually, I remember doing this curve and doing this question. It's literally just so it's so misleading. I mean, it's not misleading. It's just so intimidating. Although they put up so many irrelevant information. Although I think um hmm. So essentially, what it's asking is area here over area of this triangle. That's essentially all the question is asking. They make it so intimidating, but yeah, it's actually not that hard. So the area of here is just so x. Actually, we want to integrate from 1 to 0. X take away b take away 1 over b x squared plus 1 bx dx. X take away b take away 1 over b x squared take 1 over x dx take from 1 to 0. We want all of it to have, so bx take away 1 b I know that's, oh wait, no, we can just b take away 1 over b x take away, oh right, then yeah, then we can, since I just made it denominator, then b take away 1 x, then these are just coefficients which can be pulled out, so b take away 1 over b integral from 1 to 0 x take away x squared.
ベジタリアンチーズトースティー
はい
いる
それじゃあ
半分
okay, then we can just integrate that, so b take away 1 over b half x squared take away 1 over x cubed from 1 to 0, but then the zeros just don't even matter, so b take 1 over b of half take away 1 over 3, which is equal to b, which is equal to 1 over 6, so b take away 1 over 6b. Area beneath the equality diagonal. So this is the area between the curve and diagonal. So the area beneath here, that is just a triangle with a base and a height of 1, so that's just half, so b equal 1 6b, so area beneath the equality triangle is just half this, and we want to see what, what is the b for 20 over 63. So 2b take away 2 is equal to 120b over 63. 126b take away 126 is equal to 120b. 6b is equal to 126. 126 divided by 6. B equals 21, I believe. Oh dear. Consider a regular cylindrical tank with water to high H. The water is being emptied freely through a rigid spout of fixed diameter D located at the base of the tank. The diameter of the tank is the diameter of the the diameter of the tank is D. The diameter of the spout is D. Let H be the height of the water in the tank at any time the water is passing out of the spout with velocity V equals square root 2 GH, where G is constant. Should the time taken for the level of the water in the tank to drop from H1 to H2 is given by this. So um hmm um so how would I approach this? So volume is equal to the volume of the cylinder is equal to yes actually no not the cylinder. It's just the height of the water is equal to volume is equal to no, the diameter is D over 2 pi pi D over 2 squared times H, which is equal to pi D squared H over 4. And if we differentiate this in relations with H, it'll give pi D squared over 4. Actually, then I think the volume. So I think the way that the volume is getting empty is this volume times the velocity. So D over 2 squared pi times V is equal to dV over dt. And velocity is just squared to GH, so pi D squared over 4, and velocity is squared 2GH is equal to dV over dt. actually, can I, is it possible, is it possible to replace TV? So TV is, I'm getting this to here, so dv is equal to pi d squared over 4dh. Then, can I replace this with here? So pi d, right, okay, yeah, pi d squared over square root 2gh is equal to, actually let me just bring that dt here, to pi d squared over 4dh. Then let's just cancel these out. D squared, actually 2gh hdt is equal to d squared dh. Wait, I don't know whether I'm going the right direction or not. I think then d squared 2g dt is equal to d squared over square root of h dh. Then we integrate both sides. So integral of d squared square root of 2g dt equal to d squared over square integral of that dh. We're just integrating this with in relations with t. This feels very awkward. 2d squared square root of h plus c when time is equal to, when time is equal to 0, then 0 equals to 2d squared square root of h plus c. So c is equal to 2d squared square root of h. I seriously don't know. Right, how close am I? Actually, wait, I think I'm getting close since d squared square root of g t equal to 4d squared. Actually, I might 4d squared square root of h. Then time is equal to 4d squared square root of h over d squared square root of 2g. Then we get so we can pull out d over d squared here. Then then 4 over square root of 2g. Can we pull out times square root of h. Wait. Okay, so I have returned. Did I go wrong? Somewhere square root 2g. And that's 2d squared plus. Oh, wait. Oh, c is equal to. Wait. Is c negative 2d? Is c negative 2d squared, right? Oh, it's. Right, actually, if c is negative, then. But, wait, no, that means c is. That means there's 0. Right. So pi. So we have gt pi over 4 d squared. Then we have d squared over h dt. Oh wait, I think. Oh wait. Oh wait, no. Since we have since we're considering from like h1 to h2, and we're considering time 1 to time 2, which so time 1 take away time 2 is just change in time, which is what the question is asking for. It's just so there's no constant here. So it's just t from t1 to t2, and change in h from h1 to h2. Yeah, that. So c is cross these two lines out. So 4d from h1 to h2. So it will just be. Oh no, it's just 2. It's just 2d squared, and that will also. These two will also likewise be 2 h1 to h2, h1 to h2. That's 2. That is actually is it 2? Wait, 2, right? Right. Yeah, actually, yeah. That translates to d over d squared square root of 4 square root of 2g, and that's just, and then there's just h square root of h1 equals square root of h2, which is equal to d over d, or square root of 2 over root of g, h square root of h1 equals square root of h2. That's just, and that is what we got after. That question was just really balked, my opinion. Question 4. Question 4a. Find the values of x for which 4 take away 2x plus log x is less than 2. Log by is equal to x, b to the power of x is equal to y. Actually, there's an inequality. Right, well, which side would the inequality be? Right, 2 to the power of, right, 2 to the power of 3 is equal to, is greater, is this than 9? So, actually, no. We can rewrite log 3 9 is equal to 2. Actually, so normal basic log rules will apply. Log 3 of 4x take away 2x squared is less than log of log 3 of not, is actually, let me just check. Surely I'm not on crack. Yes, I'm not on crack. Then we can take log 9 base of 3 from both sides. Log 3 squared take away log 3 of 9 equals to 0. Oh no, that's less than or equal to 0. Actually, no. This is still an inequality. Actually, no. This, you can just cancel these two out. So x take away 2x squared is less than or greater than 9. 0 is less than or equal to 2x squared take away 4x plus 9. Right. We just check the discriminant. Right. X equals negative b plus minus b. Take away 4 times b squared. Take away 4. X equals negative b plus minus square root b squared. Take away 4. AC. That's. Oh no, that's just for the solutions. And that's just if it's equal to 0. No, it can never be equal to 0 then. So it's never equal. So it's not equal. Right. No, it's not. If it's not equal to 0, it's either this or this. But since this is a positive, it has to be this. Can I just then I just say x equals 0, 2 bracket 0 squared, take away 4 bracket 0, it's 9, which is equal to 9. Therefore, all therefore all values of x will be true, but we need to remember but it must fit original log stipulations. So 4 minus 2x is greater than 0, 2 is greater than x, then x has to be greater than 0. Therefore 2 is greater than x is greater than 0. I mean 2 is less than x than less than 2 is greater than x than is greater than 0. That's good. X squared, show that x squared plus y squared take away 4. Okay, so question 4b, let's just get those into y take away 2 squared 115 is equal to 164. So x take away 8 all squared plus take away 10 all squared is equal to is that 49? Yeah, 49. So tangential. I think by this that they mean like so here's a circle, and at this point, and they touch at this point. So so this is a circle with a radius of 7 at 8, 10. The other one, actually let's just check the other one first. Y squared 25 plus 16 is 41, so x plus 4 is equal to 36, so they both have. So this is 8, 10, and this is negative 4, 5. I think, and so since this, this is not drawn to scale, but this has a distance of 7, and this has a distance of 6 because of the radius. So actually I don't, wait, can I Wait. Can I just equate them? I don't think I can. Wait. Can I just equate the two? Oh, actually, I just create. It just creates one. I don't know about. Just creates. Oh wait. -4, 5. Oh. This is actually in this quadrant, not this one. um, well, actually, I could do square root of take away x1 squared plus y take 1 squared. We can do that one. So we know that this. So we know because they're tangential, this creates a straight line. So um 8 take away -4 squared plus 10 take away 5. Take away 5 all squared, square root of that. Square root of 12 squared plus 5 squared, which is equal to 13. So, and then I think can we just put? I think we can just put this into ratios. So, 6 times 8. Wait, let me just do it more nicely. So this one of the circle is at here, and the other circle is at 18. So around here. Oh no. Oh wait. This is -4, 5. This is 7. Then so this is 18. 18. So I think we can just take the ratio. So this equation we created before is this thing. Oh, it's actually supposed to be a bit more here. Can I create more than one circles in my calculator? Connects. And 10 and the radius is 7. No, okay. I don't know. 8, 6, 7. So, wait, how can I? So if I just drop here, so this this line is this. So because how do we know? Right, so no, this goes up by x, so it goes up by y. This goes up by this x1, y1, x2, y2. So x2 plus y2. Negative 4 plus x is equal plus x1 is equal to 8. And that's x1, that's y1. You take away x2. 5 plus y1 is equal to 10, take away y2. Then x1 plus y1, x1 squared plus y1 squared is equal to 6. X2 squared plus y2 squared is equal to it's equal to 36. This is equal to 49. What if we add the equations together? So plus x1 plus y1 is equal to 18 take away x2 plus y2. So x1 plus y1 plus x2 plus y2 is equal to 17. Actually, I might just square both sides. I might just x2 plus y2 squared is equal to 17 take away x1 plus y1 all squared and you know that x1 it's 36 plus 2x y2 is equal to 289 take away x1 1 x1 plus y1 is 30. Oh, no, that's not 36, that one's 49. Then, right, then we also get 2 x2 y2 is equal 289 plus 49 plus 30, take away 36, which is 2 brackets x1 plus 1 is equal to 3. 2, oops, where did I go? I'm already at my last page. So x2 y2 plus x1 plus 1 is equal to 151. x2 y2 plus 17 take away x, take away y, what? X2 take away y2 is equal to 151. Then take away 17. x2 brackets y2 take away 1 y2 is equal to 134. Alright, actually, can I? Oh no, I didn't think there's any way to. Actually, can I just use ratios to solve this? just, I don't know. Um, so that's 6, 4, 5, then 7. I don't know. Oops. That's x1, that's y. x1 plus x2 is equal to, so x1 plus x2 is equal to 4, then y2 plus y plus y2 is equal to 15. I don't know. Oh, wait. Oh, wait, so we can use ratio and use, so this goes up by 6. And, wait, what? Wait, let me see. Yeah, this goes up by. This. So this goes up by no, okay, so 6 times. Wait, so we can just talk about the ratio, and so this radius is 6, and it goes to the center, which is 8. So 6. So 6 times 8. Oh, this is for the x-axis, by the way. Plus this distance is 7, and this is -4. So 7 times -4 all over 6 plus 7, which is over 6 plus 7, which is equal to 20 over 13. And we can do vice versa. 6 times 10, I think. Yeah, 6 times 10 plus 5 times 7 plus 5 times 7 all over 6 plus 7, which is equal to 95 over 13. Okay, last questions. Just spin a bit more. Given that so 1 over z is equal to over a plus ib plus 1 over plus ic. I think we want to 1 over z, a take away ib over a squared plus b squared plus 1 over a squared plus c squared, a take away ic. Then we want to equate, so a take away ib begets a squared plus c squared plus a take away ic ci gets a squared plus b squared all over a squared plus b squared and a squared plus c squared. Then we take the conjugate, I think. I mean, no, we just flip it since this is equal to 1 over z, so z is equal to a squared plus b squared, a squared plus c squared over a cubed plus ac squared, take away a squared bi, take away c squared bi plus a cubed plus a b squared, take away squared ci, take away b squared ci. Okay, so let's group them together. So a squared plus b squared, a squared plus c squared over 2a cubed, plus ab squared plus ac squared, yeah, then we just took the little minuses, so take away a squared b plus bc squared plus a squared c plus b squared c, or I. Then we take the conjugate. Oh, there probably was like a way more efficient way to do this. Yeah, there's definitely a way more efficient way to do this. Real parts of Z. Let me see. I don't know. I can't be bothered expanding all of this. So 1 over Z. Oh, actually, no, I did. I probably should have just like a plus ci plus a plus bi all over a plus ci, a plus bi, then just take the reciprocal. So then we just take the reciprocal. So a plus ci, a plus bi. So that this is 1. So this is 1 over z is equal to this. So we want to take the reciprocal. So z is equal to a plus ci, because a plus bi over 2a plus b plus ci. Can I? Okay, no, I was seeing if I can convert that to somewhere down here. So a plus over 2a plus b ci. So a squared plus ACI plus ABI take away CB all over 2A plus B plus CI. And then A squared take away BC plus AC plus ABI all over 2A plus BCI. Then we only care about the real parts, so I think we can just square 2 square BC, multiply this by the reciprocal. Actually no, that square BC is AC plus ABI. I think we multiply this by 2A plus B take away CI over, so then there's just 2A plus B all squared plus C squared. I believe that's it. Alright. Alright. 'Wait, I missed a B here. I missed an I here. I hate this. So B I. Two A take away 2A plus 2A take CI B plus CI. Then square take away BC 2A take away B plus CI plus 2a grade b plus c I times ac plus b I all over 4a squared plus b plus c all squared. So a squared. Anything multiplied by I think that's just 2a cubed. 2a cubed. That's imaginary, so we don't ignore that. Then minus 2abc. So 2a. Oh, I know that's just so 2a times this is just. Oh no, that's just b plus c, ac plus ab. Right. Yeah, okay, I think this is just it. 4a squared plus b plus c all squared. I'm not sure. I might have made a mistake somewhere. Yeah, I don't know. I can't tell. Okay, I have done this before, so spherical ball bearing of radius 20 milliliters just fits. Okay, so B. Let's just redraw this real quick. I'm not asking for oval. Yeah. So since this is 20, and this whole length is 120. We can actually, and then so we want the next thing here to here. Here. Just rub this out. 120. Okay, so from here to here is 100. So from this point down to here is 100. So 20 over 120 is equal to 100 over R2. I believe this is what? Is this 2000 divided by 120? Right, is 20. Oh, actually no. Oh no. Oh no. This is 140. We want to extend this to here. This and this. These are not similar triangles. This and we need to extend it to here to create a similar triangle. Yeah, that great. So and then we arrange that, which gives us 100 over 7. Then actually over there is another diagram here. So yeah, we created this and this. And they are similar triangles. So wait. Right. So we have this, this 100/7. This is 20. I think we can just figure out the next. I think we can just use guess and check. So I mean no, just figuring out a pattern. So I don't know. So this length is 100/7. Right, so that's 240. Right. Right. Oh, wait. How did this? Where did this 140 come from? I just realized. Just realized where did this 140 come from? Right. It's because this is not 20 there. What was I thinking? Right. Oh no, never mind. Never mind. I'm on crack. So this is 100/7. Then this. Let me just swap everything out real quick. So the full length of here is 100. Then this full length. Right. Huh? Wait. No, what am I doing? Because okay, so this. Wait, how did I get 100? That's definitely wrong because this is 20 and this whole length is 120. Then this length is 100, and here is this whole length is 100. So this is huh? Oh, this is doing the glitch again. Okay, I'm not even gonna bother this time. So R2/20 is equal to 100 take away R2. No. 20/R2 is that 20/120 is equal to R2/100 take away R2. 2000 equate 20 R2 is equal to 120 R2. Then 140 R2 is equal to 2000. So R2 is equal to 100 over 7. Okay. Then this is 100 over so this half length is 100 over 7. This whole length is 100. Right, let me just create the third. Here is R3. 100 take away 2 times R over 7 is the length of here. Which is equal to 500 over 7. So the length of here is 500 over 7. 100 over 7. So 100 over 7. This is 100 over 7. Here is also 100 over 7. So no, this whole length. It's not 200, it's just 1. 100 take away 2 over 1. So 600 over 7. And here is 600. This is 600 over 7 over 100 over 7 is equal to then 5 7 take away R3 over R3. I believe that is what. Okay, yeah, that is this. 600 R3 over 7 is equal to 100 over 7 brackets 500. 7 take away R3. Six is equal to 500 over 7. Take away R3. Take away 5. So R3 is equal to 458 over 7. I'm not sure if that is true. Because it seems like a really awkward number to play with. Oh no, that's 6R3. Then so 7R3 is equal to 500 over 7. Therefore R3 is equal to 100 over 49. Okay. So because 22 100 over 7 over 7 to 5. I think we can just justify this is 20 over 5 over in takeaway 1. Yeah, I think that we can just justify it like this. Okay, last question. Suppose the sequence of ball bearings in the canvas infinite showed the mix of all of the ball bearings is this, so this equals 1 minus r in, I think, wait, what was this? Sum to infinity just 1 over 1 minus r? I think it was just, yeah, I think it was just t1 because the I just converges to 0. So the initial volume is 4 over 3 r cubed. Right, is it just right 4 over 3 pi r cubed? Let me just, so it's just, it'll be from n equals 0 to infinity of over 3 pi r cubed pi of 5 over 7 to n take away 1 all cubed. Then, oh no, that's 20 of those. Right, isn't it? N equals 1, n equals, oh no, this is n equals 1. N equals 1, then that's true, then n equals 2. Then is pi r cubed. Yes, so the ratio will just be 4 over 3 pi 20 cubed times 5 over 7 n times 5 over 7 times -3. 20 cubed times 5 over 7 to the power of -3. So the 3 pi times 21952 5 over 7 in, oh wait, 5 over 7 3 in, is that true? I can't, okay. 87808 over 3 pi 507 in. Sum from n equals 1, n equals 1 to infinity. Then do I just right, then just converges, so 5 over 7 times, this is just 5 over 7 times 5 over 7 dot dot dot. So then, actually, can you just 1 over 1 take away 5 over 7 cubed, is that it? That seems right. Just so 87808 3 pi times 1 over 1 take away 5 over 7 cubed. 7808 over 3 over 1 take away 7 o cubed. Is that correct? Why is my calculator not showing it as fraction? Can I just hmm. Hmm. Right. So what's 3 over, let's take away 5 over 7 o cubed. Does it what is it? Does it simplify? I can't tell. Wait, did I go pi r cubed? Wait, let me just see the marking schedule. Okay, I got this correct. Then I wasn't supposed to get this. I was just supposed to leave it as 4 over 3 pi 20 cubed in sum of times the sum of infinity to n equals 1 of 5 over 7 brackets in 3 brackets integrate 1. I'm pretty sure we were just supposed to leave it. I was supposed to leave it like this, which this we plug it into here. So 3 pi 20 cubed times 1 over 1 take away 5 over 7 all cubed, which Is it equal? 4 over 3 times pi 20 cubed over 1 take away 5. I'm gonna take away because 5 over 7 all cubed. Is that okay? That is equivalent. Okay, which is equal to 5.48 times 10 to the power 6 pi over 327. Okay, that is the whole speed run done. I mean, not speed run, just walk through. I think yes. So I think I'm wait. Oh no, never mind. Oh, I forgot to do this question. Wait, why did I forget to do that question? Oh, I'm sorry. I forgot to do that question. Should foresee. Okay, so I think x squared plus y squared xy plus, I think we want to create as much squares as possible, create the squares, so we multiply the second equation by 2 and add it to, and term plus 2 times 2. I think we just do this, so which creates x squared plus y squared plus 2xy plus 11 x plus y equals equals 12, I believe. Actually, no, yeah, we can just group x plus y squared plus x squared plus 2, yeah, x plus y is take away 12, 0, and then we can just a equals x plus y, a squared plus a take away 12 equal to 0. Equals 1 negative 12. Then okay, so if x plus y is equal to 1, that creates xy is equal to 1, I think. Wait, do we know the exact values? Because x plus y is x plus, oh no, that creates xy equals negative 2. Then do I have to substitute it? X equals negative 2 over y, so I have to substitute it into 4 over y squared plus y squared take away 6 over y plus is equal to 8. Y to the power 4. Take away 6y. 3y squared. This plus 3y cubed. Plus 4 equals 8. Y squared, I believe. So y to the power 4, take away plus 3 cubed, take away 8y squared, take away 6y plus 4 to 0, which, I think we can just put it in a calculators again. Oh no, 4 plus 3 plus negative 8 plus negative 6.4, which creates which creates y equals 2 negative 1. It's like other solutions. I didn't think they made it. No, because there's only supposed to be 2 solutions. Okay, I'm tired. I'm just gonna. I'm just tired. Just gonna assume these 2 other solutions. Then, so y equals 2 creates x equals negative 1. Y equals negative 1 creates x is 2, so negative 1, 2, and 2, negative 1 are the 2 solutions. Then we need to consider complex ones, because so we're going to get xy x plus y is equal to negative 12. Actually, I could have just plugged it in here. Right, actually, no. Wait, oh, wait, wait. Oh, no, I couldn't have. So, no, never mind. I'm crackhead. Alright, so xy is equal. So, xy is equal to. Right, so we. X plus y is equal to negative 12. So, xy plus 4 brackets 12 equals to 2. Xy equals to 50. No. Xy is equal to 50. X equals 50. Y. Wait, what did I plug it back into? Calculus it. 1 AM isn't. I substituted back into here. 2500 over y squared plus y squared plus 150 over y plus 150 is equal to 80. Y to power 4. Wait, is that real? No, there's still 3y. It's about 4 plus 3y cubed plus... No, take away 80y squared plus 150y plus 2800 equals to 0. I plug this into my calculator again. 1, 3, negative 80, 150, 2000. I get quite weird numbers. Alright, is that 2500? Okay, I get lots of numbers. I get y equals negative 5, negative 10, 6 plus minus square root of 14i. Which, so, y equals negative 5 creates... Right, 20, so that's 25, take away 15, which is 10. Oh, no way. Oh, surely there's an easier substitution. Oh no, there literally is, yeah. X equals 10, equals negative 10, x equals 5. Y equals 6 plus square root of 14i, which turns into x equals 50 over square root of 14i. That's 50. 50 over 6 plus square root of 14i creates 6 minus square root, which is equals to 6 minus square root of 14i. Yeah, okay, that is quite nice. Then y equals 6 minus square root, and I creates x equals 6 plus square root of 14i because conjugates. I think that, wait, what are these solutions? Was I supposed to get them, since this feels so weird? Negative 5, no, 10 squared plus 25 plus 30, take away 15. Yeah, these two aren't real solutions. Right. Yeah, these don't give solutions to this question. So therefore these aren't real solutions. So this and yeah, these are the solutions. Okay. Yeah, hopefully I didn't skip any other questions. Oops. Okay, yeah, I did not skip any other questions. Okay. Thank you for watching the video.